Now, what I'm going to do for this one first is we're going to try to solve this one without a graphing calculator. And then, yeah, and then I know that she showed you how to do a graphing calculator. Then we'll look at doing it with a graphing calculator as well. Because this could be a question that you'd be asked to do without a graphing calculator. So again, we're going to graph this line. What's going to happen here, I'm going to move the 2x over and move the 11 over. So I'll get negative 3y is greater than negative 2x minus 11. Divide everything by a negative 3. What do you have to remember when we divide by a negative 3? Got to flip the sign, so we're going to get y is less than 2/3 x plus 11 over 3. These numbers aren't necessarily the nicest numbers, are they? So when I go to graph this, you could think, well, what is 11 over 3? That's going to be 3 and 2/3. That's going to be approximately there between 3 and 4. Then if I went up 2, because my rise is 2 and my run is 3, I could go up 2, 1, 2, over 3, 1, 2, 3, and get a second point. Would I draw a solid line or a dotted line? Dotted line. Would I shade above or would I shade below? Shade below. And there you'd have how to do it without your calculator. Okay? Can anybody tell me some nice points? By the way, whenever you draw a graph, you're going to have to label some things. So I would label this to give an indication of the scale. This is 0, 11 over 3. We moved over 3 here, so maybe I would label 3 on that. So I have an indication of what my scale is on my y-axis, what my scale is on my x-axis, because otherwise this point could be anywhere. I might have been going by hundreds. I might have been going by 2s. So we need to have some sort of scale on our graph. With your graphing calculator, you have to change it to y equals mx plus b anyways in order to put it into your graphing calculator. Make this bigger, no. There we go. Y equals, we've got it in there from yesterday. And then you go over to the side here and push enter until it allows you to shade below. Okay? Some of you might also, under your apps programs, oh, I don't have it, but some of you might have one that's called inequals. If you push enter on that one, it allows you to see some additional stuff as well. But I don't have it. And then you hit graph, and it graphs it, and it shades below. Question for you, going back to our equation here. Can someone tell me one nice point without fractions that would be on this graph? No, 0, 0 is not on the graph. See, not in the shaded part, but actually on the line. Can someone think of a nice point that if I were doing a table of values with an x coordinate and a y coordinate, that both of those would be whole numbers? A little bit of mental math. Look at your equation. That point is right here. -7, -1. You see how I like that point because there's no fractions? Can you figure out any other ones that work out nicely like that? Should I give you another one? How about -4? Oh, -7, -1 would be down here, wouldn't it? Oh, no, look at that. Works out perfect. Okay. How about -4? What happens when I plug in -4? I'm going to get -8 and +1. Because then that would be -3 plus 11. Sure enough, it equals 0. -4 and +1. -1 and 3, good. 2 and 5. And Chris, how are you getting those? You went to your calculator and went to table. That's another way to look at which ones work out nicely. So you can see 2 and 5, 5 and 7, 8 and 9. And then you can keep going. Do you see a pattern in the numbers? If we go back here, math is all about patterns. With the nice numbers. The next nice number is 5 and 7. The next nice number? 8 and 9. Once you find one nice number, you can find other nice numbers just using your slope. Because what's happening here? I'm going up how many? 3. What am I doing on this side? I'm going up 2. This is my rise. This is my run. Because this is how much I'm changing my x's. This is how much I'm changing my y's. What did we find our slope to be? Rise over run, 2 over 3. So once you found one, then you can find other ones nicely. Okay? The problem with this question when we graphed using y equals mx plus b, we were already into fractions. It's not wrong to use those fractions, just it doesn't look as nice as labeling nice points. So technically this one's probably -4, 1. And -1, 3 was right here. And 2, 5 would be right there. And those are nice numbers for graphing. Okay, so there's just some non-calculator things, because this would still be a non-calculator question for you to graph and shade. The last example that you guys were working on